Right. Hi, everyone, and thank you for joining us today for our AIA certified webinar, Cracking the Code NFPA 285 for Wall Assemblies. My name is Kim Melton, and I will be the moderator for today's presentation. Before we dive into introductions, I do want to go over a few logistics. First and foremost is that we are working remotely, so if we come across any technical difficulties, we'll pause the presentation for up to 5 minutes to allow, see if we can solve any of the technical difficulties if they're disruptive to the presentation. If we can't, we'll cancel today's presentation and reschedule for a later date, and we will communicate that to you via email. So with that, next slide, please. We'll be concluding today's webinar with a live Q&A session with not only your host, Dwight Stone, but 2 other members of our specifier services team. And so if you would like to submit a question, you can do that via the Q&A feature to the right side of your screen. Now, if you don't see Q&A to the right side of your screen, you will see a series of circular icons across the bottom. The second one from the right, or I suppose the third one from the right, is a little question mark in a square. If you click on that, that will open the dialog box that will allow you to submit questions to us that we will address at the end. Next slide, please. I do want to point out that today's webinar is for educational purposes only and should not be used as a substitute for professional engineering design, consultation, or documentation that could be required by the building codes, contracts, or applicable laws in your area. So if you have any questions after the webinar, you can refer to our specific application guidelines and instructions, and those are located in the product sections of our website. And finally, we will follow today's webinar with a survey, and this is your opportunity to provide us with feedback on how we've done today. You can even use the survey to ask any additional questions you may have about the topic of the webinar or suggest new topics for future webinars that you'd like to hear. But this survey is also part of how we deliver the JM experience to you. Now, the JM experience is based on 4 pillars of the JM culture, and those are listed in the bottom left corner of the slide, and that's people, passion, perform, and protect. And we believe it's critical to make sure that we're hearing and understanding and responding to your needs in order to deliver the best interaction to you. So we offer webinars like this one to help educate the market and be a tool and a resource for you in your business, but this isn't just a one-way street, and your feedback is a key component to helping us evolve to better meet your needs. So if you have any questions or comments as to how we can better accomplish this, or even if you feel like we've missed the mark today, we'd encourage you to fill out the survey, and we'll use your feedback to improve our webinars and provide the information that has the most value to you in future webinars. Now, we're also frequently asked whether or not we send out these presentations upon their conclusion, but we don't send out the presentation itself. We will post a recording of it online that you can watch at your leisure or share with your colleagues if you find the information to be extremely valuable and think they might be interested in it as well. So this ensures that you can have the presentation within its full context, and we will send an email to you when it is live on our website. So with that, I'm going to hand it over to Dwight Stone to introduce himself. Go ahead, Dwight.
Hello, everyone. My name is Dwight Stone. I'm a specifier, well, actually a building enclosure specialist with Johns Manville. I've been with the company since 2015, and prior to that, I did a 20-year stint in architecture. 10 years of that working my way up to project manager, and then 10 years sort of exploring the intricacies of being an independent specification representative for my own company. Actually, I was a independent specifier, so learned it from a lot of different angles, and have enjoyed the process of really kind of seeing the technical side of architecture and how to apply that most effectively in the field. So this, of course, is an accredited presentation. 1 CE credit will be applied to the AA website, and we'll get a certificate at the end of the process. Self-reporting will have to be done on your own. And that said, let's get right into our objectives. So basically, this course is going to be an overview of topics related to NFPA 285. Testing for wall assemblies has been around for some years now. We'll start by defining a few terms as they relate to the wall system, then touch on the history of the NFPA 285 test, which dates actually back to the 1980s. We'll spend a significant portion of time looking at the actual testing process and graphics to illustrate the components of the test, and then we'll talk about the current state of adoption throughout the U.S. Finally, we'll discuss the process of designing a NFPA 285 compliant wall system, which is fully compliant with today's current standards and codes. So it's kind of a lot to chew on, but we'll get right into it. Let's start with some definitions. So why these three definitions? Well, these are elements that are required in commercial assemblies and may or may not trigger the NFPA 285 requirement, testing requirement. So an air barrier being basically they're required in building assemblies to separate the conditioned space from the exterior environment, reduce air leakage and vapor movement through a building assembly. Water-resistant barriers, as the code likes to call them, or WRBs, or weather barriers. These are exterior building elements that are designed to keep water out, basically bulk water, liquid water, keep that from entering a building assembly. These are not to be confused with vapor barriers, which are sort of an in-between product between the air barrier and the water-resistant barrier. Vapor barriers are a different element and may or may not be included as an element of either of these. Continuous insulation, this is, the energy efficiency gains from continuous insulation are well documented and are actually one of the driving factors behind the use of plastic foams in exterior insulation, which gave rise to the NFPA 285 assembly test. Seem to be losing my mouse. Here we go. And one of the first exterior continuous insulation systems, and one that actually does it all in terms of air barrier, weather barrier, and exterior insulation, is EFIS. EFIS was originally developed in Europe after World War II. EFIS started to be used in North America in the 1960s, became very popular in the 1970s due to the oil embargo, and the resultant surge in interest in energy efficiency of the first continuous insulation system. Originally, this was only installed over non-combustible masonry walls, which makes it very safe. But the use expanded to framed wall systems with some combustible elements, as we see here on the right here. So EFIS was popularized in the 1970s construction during the energy crisis. These systems had the advantage of being lighter, easier to install, low maintenance, and energy efficient when energy prices nearly quadrupled with the advent of OPEC. The shortcomings were quickly overlooked in the high inflationary environment of the 70s due to the cost competitiveness of this product. The expanded, or as the specifications call it, molded polystyrene and polymer-based layers were flammable, however, so they could be ignited from the exterior or the interior of the building given the right conditions. Some various drainage problems and perhaps installation deficiencies drove it out of many markets in the U.S. in the 1990s, but it's made a resurgence in recent years with many assemblies that have actually passed the NFPA 285 test. So there's been some recent speculation that some cities will eliminate the use of all exterior foam plastics in this type of commercial construction, but that's still just sort of a word to the wise. But that would be a significant blow to this type of continuous insulation system. Let's look at a brief history of the code requirement for NFPA 285 test. The SPI, the Plastics Institute, this was basically a grouping of the manufacturers that made foam plastics. They were aware of the characteristics of, flammability characteristics of the exterior plastics. And so we're proactive in proposing some of these testing requirements. So the original testing came out of one of their focus groups back in the 1970s, I believe. So the first entrance into the code was the method of test for, that's a very long title, I'm going to spare you, but it was originally embodied in the code in UBC 7-16. So the actual test itself was included in the code. UBC 26.4 was the successor to that graphic and that requirement outlined in the code. and it was basically the original type of test, the full-scale two-story fire test and the characteristics of that test. The purpose was to analyze how an interior fire may alter the flame and smoke propagation characteristics of an exterior when plastic insulation was associated with the exterior system. So at this point, there was not continuous insulation requirement, but there was plenty of wariness about the use of exterior plastics in non-combustible construction. So in 1997, the International Building Code did require the use of NFPA 285 for foam plastic on exterior walls. In 1998, the NFPA actually separated the test requirements out of the code and into its standalone document, the one that we see today. There's only been a few iterations of that test, so every change should be notable. But basically moving it out of the UBC or IBC and into a standalone referenced document allows it to be a little bit more modifiable from a code standpoint. So this manual extracted and illustrated the original UBC 26.9 test method in a smaller scale test. And I just want to sort of underline the fact that many of the plastic foam systems currently available today have actually passed NFPA 285 tests. These are available on manufacturer websites. I have been looking, but have not been able to find an aggregate. I guess it would be a living document, an aggregate information base for all the tested assemblies. I assume it would be very large. So the history of the test, and once they split off the NFPA 285 test, 1998 was the first edition. So it basically developed this test method through a consensus process for determining the flammability characteristics of exterior non-load-bearing wall assemblies or panels. It started with non-load-bearing. In 2012, the edition it basically refined some of the locations, graphics, testing requirements for thermocouples to be able to measure the actual heat developed within the rooms and in the exterior assembly. And the current edition now includes both bearing and non-load-bearing wall assemblies. So there are also updates to joint and seam locations and window header construction. So you know, there's modifications being made, but the test itself has remained sort of remarkably static. Really, it's testing a very specific aspect of these wall assemblies. And here is the book as it stands, 2019 edition, fire test for evaluation of fire propagation characteristics of exterior wall assemblies. Note that it's no longer non-load bearing wall assemblies containing combustible components. So it's for multi-story buildings primarily, but there is a lateral component to the test which needs to be taken into account in your non-combustible structures. So performing this test actually gives us a new understanding of the spread of flame and smoke in exterior walls, the element of it that makes it dangerous from a fire spread characteristic. New emphasis is on combustible components in the exterior walls, of course. Foam plastic assemblies, really the trigger, the original trigger for NFPA 285 was including non-combustible elements in these exterior walls. And want to sort of underline that this is completely different from a UL type assembly. It's not the same evaluation metrics, and it's also not the same evaluators. So we've got a little video here, which this is actually perhaps intentionally called the Dubai Torch Tower. I'm not sure if it got the name before or after this event, but In 2011, it was the tallest residential building in the world. It's also called the Marina Torch. It must look beautiful at night when it's not on fire. In 2015, an exterior grill actually lit the cladding system on fire. So this was technically not, I don't know, it could be seen as an NFPA 285 test from the exterior, but really the NFPA 285 test includes an interior component. It actually burned 101 apartments, removed that exterior cladding system, and with it cascading down to the streets below. And then, unfortunately, it actually lit itself up again. I'm not completely aware of the trigger in 2016. I assume it was something welding related, but in 2016, it caught fire during restoration work as well. So the positive effect of this, and what makes it sort of a successful test, is that no injuries were incurred in either event. So the egress systems, all the systems of the building were worked to allow the occupants to egress without harm. Whoops. So a study in, I call it horizontal fire, but this is really just sort of just a very unfortunate incident that occurred in China. This was in 2010 in Shanghai. An apartment building caught fire, and this was due to exterior welding. And the welding actually caught the exterior scaffolding on fire. The scaffolding had wood planks, probably had some residue that was flammable, and it lit the scaffolding on fire and ultimately the building on fire. So firefighters were unable to extinguish this building from the exterior. There was just too much flame to be able to impact it with water. It did not have the same built-in safety or egress characteristics of the Dubai Tower, and the inadequate egress resulted, unfortunately, in 58 deaths. So this would perhaps be called an unsuccessful test. These occur infrequently these days, but in areas where there are fewer code requirements, unfortunately, we can expect them. And this is sort of the classic case study that is quoted as a reasoning for all of the requirements of the NFPA 285 test. In 2014, the Grenfell Tower, it underwent a major renovation. You can see the actual tower itself on the left, sort of a brutalist concrete structure, designed to shelter in place. Did not have sprinkler systems to my knowledge, but it did not have combustible elements on the exterior. The 2015-16 renovation added a bright new metal composite system on the exterior, including a 2-inch airspace, which has something of a chimney effect when you light interior elements on fire. So this cladding system, there were two types used. One was an aluminum composite metal, basically aluminum sheets with a polyethylene core, and the other had a polyiso core. I don't know exactly which areas of the building had which, but I do know that the polyethylene is the most flammable of those materials. So that in 2017, after the renovation was completed, and part of the renovation was a VE process where the more costly fire-resistive exterior cladding system was knocked out of the budget. And they ended up with the picture on the right. So this fire actually started in a fairly benign fashion. A refrigerator and a unit in the 24-story tower malfunctioned and sparked and caused a fire in a unit. And this fire extended to the exterior of the building and caught that new cladding system on fire. So either the testing hadn't been done, or it was pre-code requirements for that specific building may have been grandfathered in. Unfortunately, this blaze resulted in the loss of 72 souls. So this was an unfortunate incident that has, I think, reawakened worldwide interest in the NFPA 285 testing. So what are we trying to do with all of these various fire requirements of a building system? For a non-combustible building, we're trying to allow means of egress, which is really sort of pushing a stopwatch and saying, okay, it's time to get out of the building. We're going to give you as much time as we can. The various components that are worked into that calculation include the height, the floor area, the occupancy group, how many people are expected to be inside, and the amount of time they're going to need to get out of that building. So NFPA 285 sort of clips into those requirements, including rated wall systems, sprinkler systems, all these different systems and elements that are designed to keep these buildings from lighting up around people, so they're allowed to escape. And what types of buildings is it required for? So getting into sort of the nitty-gritty of the triggers for NFPA 285, it's really only for technically non-combustible buildings. These are buildings that they start with completely non-combustible type 1 materials and structure throughout, and then include type 2, 3, and even type 4, which is heavy timber construction, which is designed to burn, but it's designed to burn slow and long so that it doesn't actually fall down as a result of fire. So the different elements of these structures are here delineated on the description here. You see various types of non-combustible elements with, let's say, type 2. This is perhaps the most common type. Exterior walls, floors, and roof are composed of non-combustible materials. So introducing combustible materials into those is where the red flags start to go up. And those combustible claddings are illustrated right here. Anything that's foam plastic or considered combustible, be it exterior plastic insulations, except for one-story buildings with sprinklers, of course. And then combustible claddings, including the EFIS metal composite panels, high-performance laminate, and then FRP. So these plastics materials that are being applied to the exterior for walls that are greater than 40 feet tall. So this is really adding that element of how high the building is does affect how much that fire will affect it. Combustible WRBs, this is where a recent change has been made. Including a weather-resistant barrier in that system used to be an automatic trigger for NFPA 285 testing, but now it's really just for walls greater than 40 feet tall. A lot of reading here, but this is updates per IBC 2015 and 18. So the NFPA 285 is out of phase with the code, but the code has been, the IBC has been adopting various elements of it in the new iterations. So 1402.5, we've got vertical and lateral flame propagation, basically saying what we've already said. The combustible water resistant barrier greater than 40 feet will be allowed with a 285 test. Fenestration products, interestingly, fenestration products and flashing elements, so the rubberized flashing elements we see on structures are not considered part of the weather-resistant barrier. So a new exception to NFPA 285 is where the WRB is the only combustible component in the wall, and it's covered with brick, concrete, stone, terracotta, stucco, or steel with minimum thicknesses. Some very specific engineering requirements for that WRB. And then, of course, the exclusion for exterior walls of one-story sprinklered buildings. This makes just a lot of sense. If you do have that EFIS, I mean, this is where I see most of the EFIS applied, although it's frequently applied in multi-stories. But you've got, foam plastic with a flame spread of, a certain amount. And it's covered by aluminum or corrosion-resistant steel, and the building has an automatic sprinkler system. So this type of system would not require a test. And then take that, a one-story sprinkler and covered with metal, or if each face, if covered on each face with a minimum of these masonry materials. So it gets very specific, and this is some of the comments I received from architects in the field that we like the test, except there's just so many exceptions. So it's something you have to sort of walk through carefully, like any code study. So let's get to the fun part of it, and this is conducting the NFPA 285 test. This is where the rubber meets the road in terms of how that test is performed, what elements are in the assembly, and really manufacturers are kicking out up to $50,000 per test to find out if their product is going to make it or not. And I've heard anecdotes of products making it to 29 minutes, but not making it to 30. So that's another test required with some slight modifications. So the test wall specimen is a two-story assembly. It has these characteristics and heights and widths. It has to, of course, include a window opening. Without that, there's no point in having the test, because it's really just an interior fire test then. It does also have to include a horizontal joint in the exterior veneer extending the entire width. These joints are frequently a weak point in those exterior systems, and we want to identify those on the front end. The new addition for 2019 is now it has to have a vertical joint or seam running full height starting at the top of the window all the way up that assembly. You'll see that in the photos that are coming up, that vertical joint. And this is a section of the test itself. Here's the testing apparatus. Burner 1 is right inside the unit. And then burner 2 is going to be that exterior, basically it's, when fire starts inside a unit that will start to flame out these windows. We've seen that 100 times. So this burner right here replicates that effect. So the temperature increases every 5 minutes. If at any point any one of those thermocouples detects a temperature of 1,000 degrees, the test fails. So it's a very specific test for that interior to exterior communication of fire. This is new in the NFPA 2019 edition. The location of these thermocouples have been adjusted and added into that document. And here they are live. These thermocouples are attached in and communicating the temperature of these various locations through this box. Here's one of the test assemblies. Looks like that's a National Gypsum product that they're testing. And you've got the window opening, you've got the finish going over it. And here's actually another test for a exterior insulation system with tape joints. Here's basically, as a result of the test, we cannot at any point see the flames extending greater than 10 feet above that roof opening. So they actually have the amount of BTUs being supplied to that exterior fire apparatus is specified, so that we don't get any anomalies from just gas delivery. So that it's really about propagation of flame. It also can't propagate more than 5 feet to the right of the center of the opening. So within the wall cavity itself, the flames cannot extend vertically or horizontally, and they need to stay within certain predetermined temperatures. So here's the test. In practice, we see this vertical joint here and the horizontal joints extending side to side across the entire two-story apparatus. This looks like a metal panel system being tested, and you see the results here and the height. So there's somewhere in that photo, there's a 10-foot mark, and it can't show, the flames cannot have extended above that 10-foot mark. So let's take a look at a time-lapse video of a full NFPA 285 test, which lasts approximately 35 minutes. I think it's misquoted inside the video, or perhaps it changed. There's 5 minutes at the interior, then an additional 30 minutes at the exterior. So apologize if it's a little bit jumpy, but we'll talk through this is the actual testing assembly structure. Of course, it's completely non-combustible metal. They can conduct the test indoors these days as long as it's within a smoke venting structure. This is the opening, and that's that interior test room burner, which burns for 5 minutes before exterior. There's the thermal couple placement. And there's the delineation of the 10 feet that we can't exceed. So it's a nice little facility. I believe this test was actually done in Dubai in 2017. I'm not sure if it's before or after. Here's their the torch tower, but here's preparing to start the test. Peering into the window, probably the safest spot in the test, right there, lighting that interior fire, and then burning that for 5 minutes. So you see the smoke escaping through the window and then evacuating out through the building. This is really the most difficult part of the test for wall assemblies, is that exterior fire coming up that exterior part of the building. So if you've got a plastic-based, let's say a laminate product on that exterior, this is going to be a tough part of that test. So there's the vent, the gases venting out. They are actually moving up inside the wall. Well, hopefully not, but they are being tested for movement through the wall. And this is 25 minutes into that test. Obviously, it's not propagating up to that 10-foot mark or anywhere near it. Completing that test. So after that, there's a 10-minute observation period where you see the smoldering occurring, and you actually see smoke escaping through the top of that facade. So, the measurement begins there. So at the center of the opening 5 feet out to the side and then 10 feet up, that the decision will be made whether that system passed the test. So how do we design an NFPA 285 compliant wall? This is really sort of the big question. This is a simplified chart, doesn't show all the exceptions, of course, but I find it helpful to clarify whether a system even needs to engage in the NFPA 285 test. So per the commercial code, the definitions of building types 1, 2, 3, or 4, is it non-combustible building type? If no, not required. If yes, is foam plastic used in the exterior wall assembly? Again, if no, if yes, it triggers the immediate requirement for a test. If no, is the exterior cladding itself combustible? And is it installed over 40 feet above the grade? So that would trigger the test. And then the last stage of this is the weather-resistant barrier combustible, and is it installed greater than 40 feet above grade? So Manufacturers have a vested interest in their products performing and passing this test, so that they will all post on their websites the assemblies that have passed these tests. And the way you read these, we'll go through this line by line, but the way you read these is it's subtractive. So you start at the first part of that wall system, then you add the other elements to it, and you select from the tested components. I'm still looking, and I will let you all know if there is some sort of aggregator website which has these assemblies here. But as it stands right now, these are really fairly product and manufacturer specific. So this begins with step one, selecting that base wall system. Here we have the option for concrete masonry or steel stud. All non-combustible structural systems. And then fire stopping. What is the fire stopping element to use? Well, this is fairly precise. Has to be 4 pounds of mineral wool. That's an example would be thermofiber. There are many other manufacturers of mineral products that pass this test. Cavity insulation. What goes inside between the studs? Fiberglass bats, mineral wool, sprayed cellulosic foam, which is actually that's actually a flammable material, but it's encased in gypsum, so it doesn't fail the test. And then hybrid systems, spray foam and fiberglass. Fiberglass and mineral wool are two non-combustible elements again, so those are fairly safe in any assembly. Exterior sheathing, you've got three selections here. None, or exterior type gypsum sheathing, or exterior type X gypsum sheathing. So these are usually fire components for rated wall systems, and they function just as well in an NFPA 285 test. And then here's the WRB, water resistant barrier. Lots of options there, including none when you're actually sealing the exterior sheathing, and you have basically your WRB is installed in the face of that sheathing. It can also be on a polyiso sheathing, similar to our foil face sheathing board, which can be installed standalone with tapes as a weather-resistant barrier as a part of this system as well. So this forms basically a continuous insulation as well as the WRB, and complies with the test. On top of that, the selections are becoming are illustrated here. Let's call them. You've got brick, the masonry types, the stucco, natural stone veneer, artificial stone, and terracotta. So these are all very safe exterior building types. There are other elements out there that are that trigger their own test, including the plastic-based exterior veneers and some metals. So that would be the last selection from that ESR or evaluation service report. Those things can be buried in types in other reports. So if you need copies of those, just reach out to a manufacturer and they'll be happy to send them to you. The considerations with specifications are multiple, but the sort of the safest catch-all, the method to require the use of an NFPA 285 approved assembly for that type of building is to basically state that in the specification. It needs to be part of it. Unfortunately, that's sort of casting that either onto your drawings or onto the contractor to assure that any assemblies are NFPA 285 approved. So close coordination with your detailing and the wall sections and details is important if you're going to include that. These can get very proprietary, so it'd be nice to have at least 3 in many of your sections if you want to get competitive bids. If you miss the mark on getting those coordinated, there is a possibility to back into a approved test, and that's called an engineering analysis or an engineering judgment. Basically, you need to find an engineer who's licensed in the state of the project and specializes in pirate code safety and likes to put his name and stamp on, let's say, liability-prone elements of the building. So they will be relying on various other test standards, including the ASTM E84 and these listed below. So we're getting towards the end here. Let's look at some things that are driving these the requirement for more testing, and that's primarily this requirement for exterior insulation. Again, you know, it was noted some 60 years ago that this was a very effective way to insulate a building, adding exterior insulation, which basically covers all the bridging elements, the thermal bridging elements of the structure, and insulates those. But at the same time, it has caused, you know, it's brought other elements, combustible elements, into non-combustible assemblies. So these are really the three primary product categories or buckets which most of these insulations fall into. The safest is the completely non-combustible, and this would not require NFPA 285 testing. Fiberglass or mineral wool products. These fiberglass itself melts at about 1200 degrees, mineral wool at 2100 degrees, plus or minus 100 degrees there. And that product is very safe and doesn't trigger the requirement. And then there are the two types of plastics. There's the thermoset plastics, which have a higher melting point than the thermoplastics, like the polystyrenes. So into this category is the polyisos and the closed-cell spray foam, which is a closed-cell polyurethane product. Still plastic, but the polymers do interlock during the process, which means that when they burn, if they burn, they char rather than melt. So that gives them some better characteristics during a fire in the exterior assembly. They retain their shape, so they're not melting through the system and sort of spreading liquid fire. Thermoplastic materials have the lower melting point of all three here. Softens about 165 degrees, melts at about 200 degrees, and then it can continue to burn and liquefy. So oil-based product tends to melt back into its native form. Air barriers, again, the requirements driving air barriers throughout the U.S., especially in certain criterion. These, once they get over 40 feet, become a trigger for these assemblies. Under 40 feet, there is a recognition of the fact that this is a very minor combustible element, and this line right here and this flashing material under 40 feet is not sufficient to trigger the requirement. So here's the requirements for air barriers in the International Residential Code. Air barriers requires air barriers in all climate zones 1 through 8. And for commercial built structures, climate zones 4 through 8. So this is areas where those will definitely will be a factor in the assembly. So to sum up, that's kind of a lot to walk through, but nearly all new construction in the U.S. is expected to require passing NFPA 285 wall assemblies where they are required to comply with ASHRAE 90.1, 2015 IBC and IRC, the IECC, or LEED v4. So understand the code, be prepared for what's coming. It's not if, but when. So that concludes the formal continuing education component. Stick around for our question and answer session where we'll get some of your specific questions fielded out to our panel of experts here and answered. I wanted to touch on the different types of insulation that are available through Johns Manville. We do have, of course, the fiberglass insulation, which is non-combustible depending on the type of facer that's on it. There are multiple different types of facers which accomplish many different things in terms of vapor being a vapor retarder, radiant barrier, et cetera. So anything that's anything you can dream up in terms of a cavity space, we can fill with this type of insulation. Mineral wool products, which have greater acoustic characteristics, definitely even better fire resistance than fiberglass, and come in various types of applications, including some that are silicone treated for exterior cladding systems. You can put those on your exterior wall without any worries about an NFPA 285 requirement. Blowing wool, this is very popular for multifamily structures and for filling walls and spaces between floors and ceilings. Floors and ceilings. So this can be blown in as a fiberglass. It can also be blown directly into a wall cavity, with the only binder being a little bit of moisture added to it so it dries in place and completely fills that cavity. And then, of course, we've got spray foams. Spray foams are the new kid on the block in terms of types of insulation. They're different from all the others in that they're manufactured on site, so you want to definitely have a good vetted contractor installing those. There are two primary types of that, including open cell and closed cell spray polyurethane foams. Polyiso sheathing has been around for a while. This can be above grade and even below grade. It can function as either simply a continuous insulation or a weather barrier component. And then on the lower right here, we've got a tile backer board, which is basically a polyiso board that has structural characteristics in the facers that make it an excellent waterproof backer board, as well as an exterior sheathing board for certain applications. So I wanted to take the time to go through those, and I'll hand it back over to Kim to take us through to the questions.
Thank you so much, Dwight. So before we dive into the questions, I did want to go through a couple of additional resources that we have available for anybody who's looking for either more resources or more information. And the first one I want to talk about is our specifier services team, available through what we call the JM TECHCONNECT. And Dwight is a member of the specifier services team, as are Jeff Job and Jerry Fox, who will be joining us for the Q&A here in just a couple minutes. If you have any questions, if you'd like assistance with a specification, if you're wondering if you have any additional, if you're looking for more information, I guess, about anything having to do with insulation, code, specifications, this is a team that you guys want to call. They're going to be a great resource available to you if you have any questions about insulation and how they can help you better meet codes or improve your designs. Next slide. We also have the JM SmartBinder, and this is an app that's available in the Apple App Store as well as the Android stores, where you can just download the app to your phone, and it will give you access to all of our products data sheets, SDSs, just basically the relevant product specification information that you're going to need to specify and use the products. Next slide, please. We will also be, as I said earlier, recording this webinar, and when it is live, it will be available for you on the source, and you'll be able to stop, start it, share it with your colleagues, etc. What I do want to share about the source is this is where we keep basically all of our insulation intel resources. That means we have blogs, product documentation, tools, and online training tools as well. So this is a great resource. You can access it from the JM Building Insulation homepage. It's a good opportunity to basically gather all of our informational resources all in one location. And next slide, please. Finally, we do have an AIA certification on today's webinar and an IIBEC certification. If you registered with your AIA number when you registered for the webinar, we will do the reporting for you. For IIBEC, it is a self-reported continuing education credit, so you will get a certificate of completion. And Dwight, you'll go one more slide for me. And that certificate of completion will be delivered to your inbox by this Friday, and it will be available for you to submit as needed. So with that, we're going to take it to some questions. We do have 10 minutes left here. We will go up to 15 minutes past the hour answering questions. And Jeff and Jerry, I want to make sure you guys are both available online and unmuted so that you can answer questions. So if you could just let me know you're here.
Yes, I'm here.
Kim, Jerry. Jeff. Yep, we're here.
Excellent. Thank you, guys. So the first question I'll pose to the group is, when is NFPA 285 required by code?
So we had several slides. I'll take that one. Several slides where you know, it kind of delineates the trigger points for those. I mean, it starts at the most obvious. If you've got a type 1 through 4 building, and then you've got foam plastic insulation or combustible material on the outside, including a combustible exterior assembly. But the you know, any type of structure with foam plastic on the exterior does need you know, in those type 1 through 4 categories does need it. But the combustible assemblies, anything over 40 feet with the metal panel systems, the HPL, et cetera. So we have that slide, and those are available online. Just do a quick Google search for NFPA 285 triggers, and you'll have more information than you'll know what to do with.
All right, thank you. The next question is NFPA 285 the primary means for determining the fire rating of a wall assembly?
Anyone? Okay,
I'm sorry, did you?
So basically, NFPA 285 should not be confused with a UL assembly. This is basically a very specific test for exterior cladding systems. The fire rating of let's say an interior corridor wall in a residential building would be a completely different test, and that's through Underwriter Laboratories, and those are UL rated assemblies. And there's other, I've forgotten the exact acronym, but there's other rated assemblies which really are about how long that wall will last in a fire situation. So just being clear about exterior component or insulation tested assemblies, and then sort of the interior rated assemblies. Those are completely different tests.
All right, thank you. The next question is, where would somebody go about researching testing versus tested assemblies versus approved tested assemblies?
So testing, well, you know, with the NFPA 285 test, and you know, the various other types of tests, those are specific to manufacturers' products. You know, in Florida, I come from a roofing background as well, and in Florida, you have a lot of you know, tested assemblies for uplift, which really come down to you know, which manufacturers have done the test for which type of system. And so you have it becomes very proprietary. When you have you know, the components of that test, as you saw with the sort of lined out ESR that we looked through, that shows you the various different other companies' products that can be used in line with that test, but it was with RJM insulation. So unfortunately, it's still a fairly scattered database online. So if you want to get three, you know, competing systems, you really kind of have to look through the, you know, 3 major manufacturers of the insulation material that you're using.
Hey, Dwight, this is Jeff. I want to add on to that too, just a little bit more. And you kind of touched on it briefly in your presentation as well, is that, you know, unfortunately, there's really no kind of one single repository of all this testing information, and it is kind of boils down to manufacturers testing all, you know, various assemblies as they see fit to kind of make their products, you know, more available to the industry. Just a couple of resources I would point out. ICC, the International Code Council's website, is a very popular one. They do a lot of the evaluation reports after the testing's been done. So you can go to IIC's website and search their evaluation report database. They have a huge database. A lot of manufacturers use them. We use them in addition to other agencies. A good one is IAPMO, the International Association of Plumbing and Mechanical Officials. They do a lot of similar evaluation testing to IIC or ICC. Similar evaluation reports, third-party reports that are basically kind of laying out the test information that we get from those NFPA 285 tests. And that's kind of where you're reverse engineering, if you will, all the different and various products that can be incorporated into a system kind of based on what you tested. So in theory, we're trying to kind of test a worst case scenario from a flammability, combustibility standpoint, and then we can kind of reverse engineer, for lack of a better term, a lot of these other materials and systems can now be incorporated into that approved assembly based on superior fire characteristics performance than what we tested. And the Intertech's another big one too. They do evaluation service reports. So just kind of some different, I would say those are the three biggest kind of bodies out there that are doing a lot of the evaluation reports that would be good resources in lieu of a kind of one single source.
Excellent.
Excellent. Thank you so much for that add there, Jeff. The next question is, how does polyiso insulation fare with NFPA 285?
Well, polyiso insulation has been tested, included in many tested assemblies. It's, you know, there are certain techniques to doing the test. You know, I do know that, you know, we have the polyiso tested for these masonry types assemblies. The testing for metal panel and other types of assemblies become a little bit more technical, and so those are, you know, let's say tougher to build correctly and then tougher to test. So they have actually intumescent tapes that can be installed on those, and the sort of critical area to these is that opening in the window where the fire is trying to get up into the wall cavity. And if you have, you know, an airspace in there, that gives it, you know, gives it oxygen, gives it a chimney. So the you know, there are tested polyiso assemblies, and one of those three sort of aggregator locations, ICC, IAM, IAPMO, and Intertech can definitely inform you about which assemblies have been approved and which manufacturers have passed those approvals for all different types of systems.
All right, thank you. The next question is, are decorative boards, parentheses, HPL, parentheses, NFPA 285 certified? Is there a market demand for such boards?
Well, yeah, I mean, one sort of red flag in the question is there's no NFPA 285 approved materials. There are simply approved assemblies, materials within an assembly. So yes, there are those boards. That's not really my forte in terms of which of those board assemblies have been tested. But the trigger for those is over 40 feet. So I'm sure that many of those manufacturers will, if they don't report it, then usually there's a reason for the absence, but they will definitely let you know if they have been approved.
Yeah, Kim, just to add to that, if there's a specific material that you're looking to include in your assembly, my suggestion is to go back to your manufacturer and ask them for their NFPA 285 approval. That's the most easy way, because there's a lot of materials that go in the wall assemblies, and the entire wall has to be tested. It's not just one material in the wall system.
All right, thank you, Jerry. The next question we have is, should I be concerned with an NFPA 285 for fully sprinklered one-story buildings with non-rated, non-load-bearing exterior wall construction?
That is specifically one of those exceptions. So I don't know if the trick question, but or if I missed one element of that assembly, but I do believe that the code requires those to be covered with a metal panel of a certain thickness in order to pass that, in order to not trigger the assembly test.
Yeah, right, Dwight, I just add to that briefly, Dwight. There's a whole kind of litany of exceptions with kind of that building type you just described. One would be covered with metal panel, a non-combustible material essentially, or masonry is an option. If the foam plastic has a flame spread of 25 or less and has a very minimal maximum airspace of 1 inch, that's an exception as well for one-story buildings that do include foam plastic. So I would say the answer is kind of yes and no for the one-story stuff. There's a lot of exceptions for one-story that, you can get away with that include combustible materials, but it is, there is no kind of, clear-cut, this one yes, this one no. But I would say in general, there's a lot of exceptions for those, that one-story buildings. Meaning an exception meaning you do not need to have an assembly test.
Right.
Great, thank you, Jeff. So we are up at 1:01, so I just wanted to remind everybody we will go up to 15 minutes after. If we don't answer your question in the live presentation today, we will reach out to you afterward to make sure that you do get answers to any questions that are submitted. With that, I'll move on to the next question, and the question is there any chance of a combo insulation fire-rated coated happening anytime soon? That would eliminate one of the 2 steps required.
Yeah, I saw this question before, and my impression was that they were looking for an sort of intimescent coating. A little unclear. Did anyone of the panel here have a clear perception of what the question is?
Sorry, could you repeat the question? I'm trying to answer online as well.
Yes, absolutely. The question is there any chance of a combo insulation fire-rated coating happening anytime soon? A combination that would eliminate one of the 2 steps required.
Well,
go ahead.
No, after you, Jerry.
I was going to say, we're consistently developing new products, and we're always testing new ideas with adding fire-resistant materials and trying to get certain properties out there. At the moment, I'm unaware that one that would cover both. But as we continue to develop materials and continue to develop products to combat these types of assemblies and meeting these new codes that are coming out with and meeting NFPA 285. I'm sure that we're trying to do our best to get there as quick as we can, but I am not aware of anything at the moment.
This
all right.
may also be referring to the thermal barrier that's applied over spray foam assemblies, and that's a different test. So that's the 286 test, which is really about making sure there's an ignition barrier in the right locations. And or a thermal barrier. So that's basically an intumescent paint or coating that's applied over this plastic insulation, and that would not be effective in an exterior application like a wall assembly, because basically the wall assembly is testing the entire product. The heat can come from within or without, so a coating is not going to help. It has to be an additive. There are some expensive additives you can throw into polyiso that basically put it in the, I would assume, in the mineral fiber pricing category, which again would not be as effective as simply designing a good assembly that does resist the test. So.
All right, thank you. The next question is, are there any comprehensive lists or databases of NFPA 285 tested wall assemblies?
We answered that earlier on. So ICC, IAPMO, and Intertech, the 3 primary testing agencies or aggregators would be the place to start.
All right, great, thank you. The next question is, what type of insulation is recommended for a cavity behind MCM panels?
I'll just briefly touch on this one. So when it comes, again, to assemblies, you're going to have different manufacturers putting different assemblies together to meet the NFPA 285. And with MCM panels, you have to have, again, the entire assembly tested. So that could be consistent with a mineral wool product and a WRB behind it, a gypsum board in the mix. It could be certain manufacturers have foam board materials in that mix as well. So, as a design professional, you would need to either look at some of the resources that Dwight just noted as far as tested assemblies, or if you're looking specifically for a tested assembly, We do have tested assemblies at, with JM and our partners that we are able to offer you with different panelized systems, and we can put you in touch with our partners as well. So if you'd like to use this as a resource, please reach out to myself, Dwight, or Jeff, and we can connect you with an actual assembly that would work and help you with contractor base as well.
Excellent. The next question is, how can you fasten structure to support panels through the insulation while keeping continuous insulation requirements in mind?
So that, there's various fastening methods. A couple of points to keep in mind is with that exterior fastening method. I mean, the reasoning for the continuous insulation is to cover up the metals that are basically thermal shorting through the system. So there's some fastening methods. They all have proprietary names, of course, but they the ones that include thermal breaks or include ceramic, ceramics in between the face piece and the connector piece, those are the most effective because they don't actually still communicate. If you attach Z-furring to a wall, you're basically creating a thermal short and then putting continuous insulation in between it. So those systems that have those thermal breaks in their methodology for attaching the metal panel systems are the better ones for from an energy standpoint. I hope I answered that.
Sounded good to me. The next question is, can you discuss requirements for window wall in relation to NFPA 285?
So window walls, from my understanding, would not trigger the requirement because they're non-combustible. So unless you have, if you do want insulation behind those, it would have to be of the non-combustible type, in which case, because if you introduce a polyiso or a polystyrene of those, then that's a flammable material in that assembly. So spandrel panels will be the one where you would have to just, usually it's a mineral fiber or fiberglass that's used as an insulator there.
All right, thank you. The next question is, for public bid projects under GC bidding, how do you specify an NFPA 285 wall assembly without being proprietary?
Well, it requires research. So I mean, you have to. Each one of these assemblies are proprietary to an extent. You can basically do the research on the if the plastic insulation that you're calling out for an exterior assembly, you can include the 3 or 4 manufacturers of that type of insulation, and then have the requirement that it has to be part of an NFPA 285 tested assembly. It's usually good to have in the back of your mind, that they actually did pass that, they do have those available. So once you do it once or twice, you'll know which ones have the assemblies that you need, and that will coordinate with your drawings and wall sections. So that will eliminate some of the RFIs down the road.
All right,
Dwight, I would just tack onto that briefly. I mean, I think, standard things that we see in specs all the time is included, if you're listing a polyiso or other type of foam product, is saying, hey, this product must be part of an NFPA 285 approved assembly. So you can at least list that in the specs so that they're aware of it. But when it boils down to, specifics of manufacturers, panels, aesthetics, finishes, all that type of stuff, kind of depending on what the product is, what kind of testing the manufacturer has done, you could, have a very broad array of approved assemblies available at your disposal given the materials you're using, or it could be, very limited, and then you're kind of getting into that more of that proprietary situation. If you have some very kind of unique, newer, type of panel, for example, that's, doesn't have a lot of testing, or something that the owner wants. I mean, you can kind of go a lot of different directions there, just based on the various materials you're including in the assembly, as far as kind of approved assemblies available. So I would say, you know, that it could go both ways, really just depending on what brands and manufacturers you use.
Thanks, Jeff. So the next question is, are you seeing an increase in the use of heavy timbers in construction?
I've seen an increase in the use of CLT, cross-laminated timber, and more derivative timber products. Heavy timber is a little bit difficult to procure anymore. But the CLT products, you know, you can build an entire multifamily, you know, the structure, and it can be a finished material at the same time. So I've seen that being used to some extent. I mean, it's not on a, you know, exponential growth curve by any means, but it is sort of a you know, durable and lasting component of the you know, construction matrix out there. I think in areas where it's, you know, code officials are more familiar with it are the ones where it actually has some growth potential.
All right. The next question is, does a one-story EFIS building need to comply with NFPA 285?
And that gets into the one-story sprinklered building discussion, which has a bunch of the exceptions. So you can definitely design it to not have that requirement, but you just need to pay attention to those exceptions and the triggers.
All right. The next question is the NFPA 285 test required if you're using a mineral wool as an exterior insulation with no insulation in the cavity?
No. Next.
That's a perfect answer. All right. The next question is, as per N 5.7.3.2, no material shall be used to fill air gap cavities, if any, or further, cap the header, jambs, and sill areas. Does this mean no cavity barriers can be installed with the cavity around the window opening?
Yeah, I'll take this one, guys. This is directly out of the NFPA 285 handbook. And the answer is, so there's kind of two options there. The answer is essentially no. And so per the standard they just described, no material shall be used to fill those air gaps. So that's the standard window detail construction that NFPA 285 dictates for the test. So they have very specific requirements that that they dictate to create the enclosure around the window header and jamb. It's generally supposed to be an aluminum of 0.04, no, a maximum thickness of 0.04 inches. So that's the standard detail that the test asks you to use when doing the assembly test. So that would incorporate, again, not filling any of the air gaps with some type of combustible material, or, you know, safing, or you know, fireproofing, things like that. And again, the idea there being is we're trying to kind of test a worst case scenario. So say we tested that, we didn't fill the air gaps, and then we said, okay, hey, we're going to use this assembly on a job, and we want to fill those air gaps. Then it would essentially be saying, hey, we need to get an engineering judgment to say, now we're altering this assembly, we're going to fill all these excess spaces with safing, with, you know, fire stopping material, et cetera. And in that case, that would be an engineering judgment situation, and quite frankly, I think one that would be a no-brainer, for lack of a better term, as far as getting someone to sign off on that and saying, hey, we're improving the fire resilience, the robustness of this assembly by now adding some additional fire stopping material to that detail. So I think the idea is that, yes, they don't want the test kind of dictates not doing that, because again, they're trying to achieve, again, kind of a worst case scenario. And the other thing I would mention specific to the test is the very next paragraph. If you're looking at the standard, well, not next paragraph, but N5733 basically allows for any kind of detail you want to use. So the standard detail is kind of similar to what I just described: metal encapsulation all the way around the window header and jambs and at the sill. Or you can do any window detail you want for whatever the manufacturer chooses to do. But once you use that detail and it passes, now you're, you know, you have to use that exact detail as done in the assembly. So they kind of allow for both, but I would say that the standard setup is let's kind of do worst case, metal encapsulation. If you want to do, variations thereof or specific to the manufacturer, maybe it's, FRT, jams, things like that. We see that quite a bit. Fire-resistant wood in those kind of conditions as well. That can be done as well, but it just kind of back to if you do a variation on that detail, you have to really be, you're held to that specific detail on the job site if that's the assembly you choose to use.
All right, Jeff, thank you so much. And Dwight and Jerry, also thank you for your time as well today. We are at 1:16 now, so I'm going to go ahead and draw this to a close. As I said earlier, if we didn't get to your question today, we will reach out to you directly to make sure you get the answers you're looking for. And if you submitted your AIA certification number via your registration when you registered for this webinar, we will report this learning credit for you. If not, you will get a certificate of completion in your email so that you'll be able to submit that yourself. And then for the IIBEC credits, you will receive the certificate of completion so that you can submit yourself there as well. Thank you, everyone, for your time today. We appreciate it. We hope you found this webinar informative. And we will send out an email as soon as it's live on the website for you to watch on demand. Have a great week.